next, we have Abel Brown from Nvidia. So Abel, if you'd like to come up and walk through your presentation and just give us just a quick overview and introduction to yourself in the company and what you're doing in the space.
Can everybody hear me? So my name is Abel Brown. I'm a solutions architect with Nvidia. I support deep learning projects across a wide variety of different applications and domains and industries. And so traditionally supporting a lot of autonomous driving, defense and intelligence applications, and also healthcare. And so I'm not necessarily a robotics guy, but I'm here to talk about deep learning this evening. And it's one of these techniques that has really sort of ignited a lot of recent advancements in robotics, autonomous driving, healthcare, et cetera. And it's really fueling just a ton of innovation and a lot of capability over the last 5 years and most certainly over the last 1 year or so. And so it really brings together a lot of hardware, a lot of research, a lot of data into one really great package. So this is a little dark, but in general, there's like three pieces to this deep learning explosion over the last few years. One part is algorithms. The algorithms actually existed for probably maybe 20 years now, since probably the late 80s. But what they didn't have back then was enough data to train those algorithms. And even if they had the data, they didn't have the compute power. And so it's really all three of these things that are now coming together and available in one package, in one place. So a lot of the universities doing a lot of that machine learning, computer science work to drive the algorithm development. The internet companies, probably by the mid-2000s, finally had enough data that they could train algorithms like deep learning convolution neural networks. And then finally with Nvidia creating open compute platforms like CUDA so that people can take advantage of GPU computing for general purpose problems, really kind of opened the door for people to start exploring machine learning algorithms accelerated with GPUs. The internet companies probably for a long time were the only people that had enough data to train these really big algorithms. But now in 2017, almost every industry has, quote unquote, big data. And so that's one of the big key things that you need to train these algorithms is a ton of data. And so from many, many different industries now have enough data. And so you see deep learning really coming to fruition and bringing a lot of advancements in many of these industries. And so from a lot of perception-based tasks, you now see that these deep learning algorithms, these convolution neural networks, are actually achieving superhuman capabilities for perception-based tasks. And this is particularly important for robotics. So we're seeing things that now robotics can do in terms of perception and computer vision that even just a few years ago was completely inaccessible. And certainly for things like autonomous driving, pedestrian detection, lane tracking, just detecting road signs, et cetera, reading the road signs, really making tremendous amounts of advancements here. And one of the things that you typically saw before deep learning was, hey, this machine learning algorithm has, 80% accuracy. And people would say, hey, that's pretty nice, and it sounds promising, but I can't deploy that. And with deep learning, you're really starting to see it close that last mile and get up to the 95, 98, 99% accuracy. And so that's why you really see in a lot of these fields, and especially robotics, really benefiting tremendously from deep learning. So just my final slide here, just kind of showing the ecosystem of how the modern AI, machine learning is really expanding. As I said before, a lot of the work happening at the research institutions, and that quickly flows into the big internet companies such as Microsoft, Google, Amazon. So you see that they very quickly leverage a lot of the natural language processing that's occurring here for Alexa and Google Home. And so that's one of the premier products where you'll see deep learning really making a lot of advancements. Then it's quickly pushed out as internet services. So these companies are really making cloud services available to leverage a lot of machine learning, deep learning services. This is fueling a ton of startups. There's $5 billion in funding last year for startups, for machine learning, for deep learning. So a tremendous amount of funding in that space, and it's quickly being gobbled up by a lot of the industry leaders for autonomous driving, internet services, et cetera. So just a really healthy ecosystem there, really a ton of competitive advantage going on. So it's a really great time for data science, machine learning, and robotics. So, thank you.
Thanks, Abel. Thank you. And let me pick up this sign so nobody trips on it here real quick. Abel came in from out of town, so traveled from the Carolinas. So, do think of ways that, you'll hear how Nvidia plays a part in the ecosystem. So continue to think about ways that, that they could be useful on, some robotics initiatives. Great, so let me queue up the next slide. I'll go ahead and queue up the video, and then once the video finishes, Panos, then you can come on up and we'll do a quick intro. If I can find the cursor, it is, there it is.
The exciting thing about this technology that we have is the ability for the car to perform what are known as aggressive maneuvers. So during turns, for example, the car is literally sliding around the turn. It's not maintaining its complete contact with the road surface, and yet in spite of that sliding maneuver, which gives us a lot of speed in the turns, the car is actually stable and safe in navigating this particular feature of our track.
The algorithms that we have developed are able to project into the future what the vehicle is going to do in the next 3 or 4 or 5 seconds and generate approximately 2,000 or 3,000 possibilities of what is going to happen. And based on these possibilities, it chooses the best one. And this can be done very, very fast. I think we're calculating about 2,000 different possibilities every 15 milliseconds.
This algorithm will have a broad impact. It doesn't have to be within aggressive driving. It can be within any domain within autonomy. We can think about tasks that relate to locomotion, manipulation. You have a robot and you want to be able to manipulate objects. Everything that involves essentially controlling of a system, of that is very nonlinear, is very uncertain. You don't know exactly how it's going to react.
Very good. So please welcome up Panos Tsiotras, Associate Director for Research Institute at the Institute for Robotic and Intelligent Machines, and an esteemed professor at Georgia Institute of Technology. I know Panos has a long history and career of developing papers, a lot of great work in robotics. He's also a Purdue grad too, right?
Yep, that's correct. Yep.
So welcome.
Thanks for the invitation. What you just saw is an example of what I call, one example of the exciting work that we do at Robotics, the Institute of Robotics. As I mentioned, I'm the Associate Director of Research. I'm also Professor at the Aerospace Engineering Department. And this is an example of what I call Robotics 2.0. A lot of people ask me, what's a big deal about robotics these days? We had robots since the 60s. But it's not your father's robot, right? Robotics 2.0 has to do with systems that actually have an increased levels of autonomy. Systems that actually learn and adapt to unknown environments. And there is a big difference between traditional robots that typically work in automated, what I call automation applications, and robots that actually have intelligence that allows them to react in environments they have never seen. Essentially, these are robots that reprogram themselves and can reason in situations they haven't seen before. And that is going to change everything about robots and what you know about robots in the future. And along with some of the techniques that have been developed in the last several years, artificial intelligence, machine learning, deep learning is going to have a tremendous impact, economic impact in the next 30 years. So I'm hoping that we have the opportunity to discuss all that during the panel, and I'm looking forward to the panel. Thank you very much.
Great, thank you, Panos. I'd like to introduce our next panelist, if I can find the cursor again. Try that. please. I'd like to introduce Caleb Clark, co-founder of Winston Robotics. Caleb, come on up. Caleb's been working on, in his company, he's working on some very top secret projects. That's why I had to obfuscate the photo and the picture a little bit for you. Thanks, Caleb.
Awesome. Not quite top secret, but we have some patent things we're still working on, and we can't show the actual robot yet. But we're actually in testing in an apartment building right now in Atlanta. So what we're doing is we're building autonomous delivery robots that bring things directly to your door. So they operate inside big apartments, big condos. Two pieces to it. There's the robot. His name's Winston. The company's named after him. And he's a 4'11", humanoid-looking, rolls around robot. We do a lot of AI around facial recognition, natural language, and some on the navigation. In essence, we have, he's like a mini autonomous car, in essence, with LiDAR and that sort of things. And then we have the storage and automated storage and loading mechanism. So we have 50 different items that he's been designed and that he currently is able to handle. So everything from, if it's 10:30 at night, you don't have you're out of toothpaste, you just text him. He has a cell phone number. You text him, he gets he connects your cell phone number to your apartment door, and 3 minutes later, there's a knock, and he's there with your toothpaste. Packages, mail, dry cleaning, etc. So the idea is there's a lot of companies focused on the last mile of delivery, and we're focused on the last step. So when the autonomous car with pizza gets to the outside your condo building to the curb, how does it get to floor 7, number 706? That's what we're focused on. So we've been working for about 2 years now, a little over 2 years, and as of about 2 months ago, we're now live testing here in Atlanta. So that is what we do.
Very good. Thank you, Caleb. And I know you can keep the mic, I believe, and if the rest of the panelists, if you all want to come up and take a seat, we'll get started with the Q&A or the actual panel question segment. Okay. And go ahead and take that one. Great. And I have my questions on my cell phone, so it'll look like I'm texting away most of the time when I look down. So let me go ahead and queue up the first one. Are we okay? Are all the mics hot?
Check.
Yep.
Okay. Great. And I'll start the first question, and we'll just start with Abel and go down the line. And with each question, each of you feel free to respond, and follow up on the previous person's response. And so first question, I'll start with Abel. The second question, I'll start with Panos and just continue to rotate. So then we'll spend probably, I'm trying to look at what time it is, but we'll stop at about 1:45 to take questions from the audience and then round it out after that. So let's go ahead and get started. Great. It's rough getting old. Can't read anymore. First question, Abel, let's go ahead and start with you. So how are leaders around the world defining robotics and AI? I know you work with quite a few organizations, companies, big and small, but what do you see and what do you hear as far as a definition around robotics and AI, and is there, are there arguments or discussions and difference of opinion?
I think probably, it may be right or wrong, it's probably, I think robotics and AI is pretty synonymous with automation. And so I think a lot of people, when they think of that, they think of automation. I think automation has been around for quite a while. Certainly, folks maybe like Elon Musk have a more colorful view of what AI is and maybe its broader impacts. But I think in general, a very functional opinion that is very widespread is just AI, robotics, and automation.
Okay. Panos?
I try to be these panels, you have to be a little bit controversial in order to create,
Absolutely.
a bit of excitement. So I kind of disagree. The reason I disagree is that AI these days is not automation, it's autonomy, and there's a big difference between automation and autonomy. Automation is what I called, again, before robotics 1.0, robots that do the same thing over and over again. Autonomy is a completely different ballgame. You have a system that reacts in new situations haven't seen before. And although robotics, we have what the definition, everybody kind of feels what robotics is, since the 60s, it's not clear yet, actually, what artificial intelligence means. People actually think about what's the definition of artificial intelligence. There are different definitions, people have different opinions, to the point that actually a lot of people say that we should not call it artificial intelligence because it's a misnomer. Maybe we should call it machine intelligence. Machine intelligence to distinguish from human intelligence, because machines are good at certain things, humans are good at different things. Now, things are blurred, of course, and we don't know, people start talking about superhuman intelligence. So I would not say that we actually have a good definition, especially for AI. Okay? And again, I prefer myself the term machine intelligence to describe the state of the art right now, as opposed to in 50 years to the future.
Caleb, would you like to pick a fight?
My only fight is with all the companies out there that use AI. Like, everybody has AI, even when they're not doing anything related to machine learning. And I just feel like AI has been taken over in many ways by the marketing departments, whereas robotics is still, by and large, a pretty clean definition.
Very good. And if there's any fallout after this event, I'm buying the beers to patch things up. So thank you. Great. Next question. We'll start with Panos. So why are companies looking to build and leverage robotics and AI? So worldwide, there's probably differences in Asia versus Europe versus North America. What are you seeing as far as the motivators and the drivers for companies or people to develop, and is that different from continent to continent?
Let me think about it. I think that obviously there are reasons that automation, autonomy, this type of robotics and AI will create benefits in terms of performance and cost and things like that. And I think what drives what's going on these days is economic impact. And I just want to give you a couple of numbers if you're not aware of these numbers. So there was a study that was published by The Economist about 2016. That was actually a report of a study conducted by Bank of America and Merrill Lynch. And they mentioned that about 2020, robotics and AI is going to be, the economic impact is going to be between 14 to 30 trillion dollars. Another statistic was that about 2020, the AI robotics is going to be, market share is going to be 150 billion, and about soon after that, it's going to be the largest, biggest market about any industry, 2030. So these are enormous numbers. So I don't think any industry can stay away from this revolution that's happening because of AI and what is enabled to do, and we can discuss some of the enablers later on. But I think, of course, it's economic impact number one that drives all this technology and all this research going on these days.
Thank you. Caleb, any response or additional insight?
I think it's AI and robotics is being driven by the same thing that drove humans to create the wheel many years ago. It's how do you make things faster and do more with what you have, and that's AI is just and robotics as well is replacing a lot of jobs and creating a lot of new ones at the same time.
Now you were in Europe a few weeks ago, so I know you can't share a whole bunch, but are you seeing differences in Europe versus North America in the way they're approaching it, or is it is it on the regulatory side, or just in general?
The funny thing is, about 2 weeks before I went over, I went to Bulgaria, and about 2 weeks before I went over to Bulgaria, I was sitting down with a startup here in Atlanta that does flight search, and they are working on some AI around predicting airline prices. And there are a couple companies that I was working with over in Bulgaria, and one of them had some things related to flight search as well. And we spent about a day. They started wanting to talk about the work they've been doing with AI on predicting airline prices. And it was kind of just funny, you know, it's whatever you're in these days, whether it's law, farming, airline, predicting airline prices, it's AI is the future. And either the companies are going to get behind it and be a leader in it, or they're going to be gone, I think.
Sure. And Abel, what's Nvidia see as far as drivers, you know, from, you know, what kind of requests are you getting, and what's motivating people out there?
Certainly, I think probably you know, what's motivating people, I think, is certainly autonomous driving is you know, one of these holy grails of the technology, and so I think, you know, from a impact standpoint, autonomous driving would have just a tremendous impact. And I think if you look at sort of the economic and health impacts right now of just, you know, if you just look at accident rates, that alone, if we can solve those with autonomous driving, will be tremendously impactful.
Okay, great. So I'm going to move to the third question. The third question may be a little bit redundant, but it gets to the value, right, that either your companies and your groups are seeing, or maybe even from kind of the broader business group. But let me state the question is, so what value do companies expect to get out of robotics and AI, and will they continue to grow? Such as new products or products, features, faster time to market, that kind of stuff.
I think more than anything, it does automate, does cut costs, but I think more than anything, it opens up entirely new fields, just new ways of looking at the world. And I came of age towards the end of the dot-com era, and I remember being real disheartened at certain points in discussions with friends of why couldn't I have been born where I could have taken advantage of the computer revolution that came, you know, in the late 70s, early 80s. I kind of felt that was just a time where a lot of things happened. Or even like early 90s, because I love to be on the cutting edge of things. You know, when the internet was really in the early days before the commercialization really took off. But over the last couple of years, I've just come to have this gratification for being in this era. I think more is going to happen over the next 10 years and more transformations in the world around because of AI and robotics or as much. There would be as much disruption, as much change, as much excitement as happened during any of the early 90s or the late 70s.
Just faster.
Just faster. Yeah.
Yep.
This is a disruptive technology, and when I talk to people who are not in the labs, as we are, and we know what's going on in the labs, and they tell me, wow, this is amazing what you know, Google announced. I said, you haven't seen anything yet, because if you see what's going on in the labs right now, which is going to be commercialized in 5 years, your mind will be blown away. So, so there is a lot of things happening. Going back to the question about what technologies, right? I give you one example that I think everybody's familiar with, personalization. You give the capability to personalize the product and to do the product specific for a particular customer. Recommender system is one example, right? And Google and Netflix are masters in that, to pick up exactly what you want, the targeted the product to you. So all these things will not be able to do if you didn't have this type of you know, machine learning, AI type of things, right? So this is one example of how technologies, companies, that have to think the way they produce and they market their products in the future.
Yeah, and you know, just to add to that, I think that certainly with things like deep learning, it's sort of like this one technique that you can apply over and over and over again to many, many different data types, to many different problem domains. And it's really shocking how you can just apply the same technique over and over again and get some outstanding results from image data to audio data to text and speech. And so it's really kind of, you used to have domain experts in every one of these different data sets, and they had to come up with these special features of the data based on their 25 years of research in that field, and then write up an algorithm to extract them, et cetera. And now with deep learning, these convolutional neural network approaches, you're really kind of just able to throw the data into a big bucket, do the training algorithm, and out pops a really fantastic result. And certainly that's not, to advocate not being sort of aware of your data and understanding what you're doing, but certainly it's a tool that's allowing researchers and companies to achieve more in much less time at a much reduced cost, and be much more agile and dynamic, and really kind of realize that competitive advantage.
Very good, great insights. So let's move to disruption. So of course we have to throw that term out, and really, this technology and this confluence of technologies certainly has some disruptive capabilities and aspects. But what is I'll start with Abel. What's the disruptive impact of robotics and AI for companies, for consumers, and for competitors?
Yeah, I think that probably kind of goes right to the, what I was just talking about. It's really sort of deep learning has become really kind of this single technique that is really allowing people to take sort of a unified approach to many different problems. And from everything, even if you just take some of the medical examples, we were just talking to some folks that were developing a system to look at malaria cell scans. And now they've published the neural network on a phone, and they've created the eyepiece that can attach to a microscope. And now you can get highly accurate malaria scans all over the world, anywhere in the world, just using an Android phone. And so if highly disruptive medical things like that are coming online, to where it gives people access to very high level, highly accurate data analysis that just even a few years ago was not possible. And we see that happening all over, from agriculture to utility companies, et cetera, that can now automate things, like scan thousands of kilometers of utility lines, looking for problems in the infrastructure, et cetera, and they can automate all of that and make that a routine process. So it really, all of those types of technologies are really leading to a lot of competitive advantage and disruption within the industry. Mm-hmm.
And Panos, are you seeing new applications that are highly disruptive from other labs that you could talk about? Some things you can't, but.
I'll mention a couple of examples, and then I'll let you think what the possibilities are, right? So when discussing about disruption, there is a tendency every time you have a new disruptive or revolutionary technology, it's whatever I say may be wrong, obviously. We have the tendency to underestimate the impact of new technology in the short term, and actually underestimate the impact in the long term, right? So just give an example, maybe two examples. One is most of you are familiar with self-driving vehicles. It's not clear that people comprehend the impact of this technology. It's not the fact that you're going to build a system that will drive from point A to point B. It's going to impact the way cities are built. That if you don't need to park vehicles. Most people, if you don't realize your car is basically sitting in a parking lot almost 22 hours per day or something like that. You drive maybe an hour, right? If you don't need that, then you get rid of parking lots. You make these parking lots parks and other things, right? So there is how things and cities are built is going to change just because you have these robots, right? Personalized medicine. You can have the capability of building, of creating drugs were specific for your disease, to your gene. Right? You can do things like that you couldn't do before. Mm-hmm. So these are some of the things that I think will disrupt not only the economy, but also the way that the society, to a certain extent. So. Mm-hmm.
We've all heard the phrase from Ben Horowitz, software is eating the world. I think the wild thing about what's coming with AI and robotics is with the two of them, they're eating the world from two different directions. AI is eating it from a lot of the mental jobs, and I mean everything from the stock market to I mean, all the pieces of big data and, that Abel was talking about. And then you have robotics that, with AI in it, is eating it from a lot of the more physical jobs.
Is eating a positive thing?
It can be positive or negative, but it's disruptive. And I think, and even though with the huge rate of technological progress over the last 50 years, since the advent of modern computers, much of the world is stationary. But I think you fast forward 20 years, and robotics, we might today think of it as a robot that you maybe see in the movies or in the labs. But think about all of the physical devices and items that we have in our world, and a lot of them will come alive. And software will be part. I mean, it's the cameras will be moving around on their own to try to get the right shots. We all leave the auditorium. Maybe it'll be an auditorium where the chairs will move back into place, right? I mean, who knows exactly what's going to be automated, what's not. But the point is that there's just this huge disruption from both the physical jobs and the more mental thinking jobs that I think will just open up entirely new worlds of what I hope would be convenience and luxury, and the ability for the human race to focus more on creative endeavors. More writing and more songs and more doing the things that we enjoy.